All right, I'm trying to keep this video very short because I am about to run out of time. So I'm going to tell you to hit pause multiple times, and during that time you need to hit pause and do whatever it is that you're supposed to do, because if all you do is copy, you're not going to learn anything. So right now I'm on page 9 of your packet, and I want you to hit pause and complete this warm-up to the best of your abilities. When you're done, resume. So if you graphed this one correctly, we always start at the y-intercept. This is where we start. And so I'm going to start at +3 on the y-axis. And then from there, this is my slope. It's going to tell me how this line grows, which means I'm going to go up 1 over 2. So up 1 over 2, up 1 over 2. And technically, once you have 2 lines, you can go ahead and extend your line from one edge to the other edge. The next one, I'm going to start at -1 on the y-axis, and my slope again is 1/2. So up 1 over 2, up 1 over 2. And finally, I'm going to start at -5. And again, it's up 1 over 2, up 1 over 2, up 1 over 2. So if you need to make corrections, hit pause and do that. If you did not answer this question, hit pause and consider, what do you notice about these graphs? I notice that it looks like they are moving up and down from one another, but they all have the same slope. And if I look at the equations, I can see that they all have the same exact slope, but they do have different y-intercepts. What we're experiencing right now is known as transformations, and that's what today's activity is about, is when we make little changes to the graph or the equation, such as changing the y-intercept, and the impact we see on the graph when we've done that. So this page, you've already seen all of these images, so I'm just going to talk about them really quick. We've talked about how there are different family functions. We have the linear function family, the quadratic, exponential, radical, and rational. Unit 4 is all about the linear function family, and we can tell it's linear because the graphs make a straight line, the table grows by a constant amount, and the equation always starts with or it doesn't start with, but it contains x to the first power. This is technically to the first power. This example in this box down here is the parent function. It means it's the most original, most basic version of a linear function. And anytime we have something different than what you see here, it's a variation of the original. And so we're going to explore those transformations. I want you to turn to page 11. Turn to page 11. So you're going to get 4 different colors. You can use the colored pencils in the bins, or if you have your own stuff, you can use that. And you're going to complete this entire page. You can work with people around you, but you're going to complete this entire page, coloring it all in, and then hit pause until you have finished. So if I take a look, this is what they should have looked like. Okay, and we'll talk about each one. If yours doesn't look like this, go ahead and hit pause and fix it. What do you notice about this particular page, or this box? What we're meant to notice, and if you haven't filled that part in, hit pause and answer that question for yourself. I'm going to go over it, but it's important that you try to identify any kind of patterns before we discuss them. So hit pause. What I notice is it looks like these graphs all have the same exact slope. They all look identical except for they're shifted up or down from one another. So what do I notice? I would write that they shift up or down from one another. If I look at the equations, what I notice is once again that they all have the same exact slope, and the only thing that changed was the constant, which is the y-intercept. What's the constant here? +0, right? When all that's happening is it looks like it's shifted left or right or up or down, it's known as a translation. And being able to describe that it shifted up or shifted down is part of understanding how to transform linear functions. If this next section you did not do correctly, hit pause and fix it. If you have not addressed what you notice about this section, hit pause and record your observations. What you're meant to notice here is that if I look at the equations, all of the equations show +1. The only thing that's different is the number in front of x every single time. And what happens is they all end up sharing that point at +1, but it looks like they've all rotated from one another, or the steepness has changed. What other words could we use? Rotating, steepness, kind of looks like maybe you've stretched it out or pressed it back down. Any other kind of words that you might use to describe that. And so that means that when we change the slope, we're changing its steepness. If your graphs do not look correct, hit pause and fix them for this last section. If you have not answered these questions about what do you notice, hit pause and fill in those observations. What you're meant to notice is that A and B look like they belong together, and that C and D kind of belong together. So here, C and D belong together, A and B belong together. That's why I highlighted the second set of them to show that these ones are meant to kind of belong together. And what you notice is that these equations look exactly the same. The only difference is this is a positive slope and this is a negative slope. And what that does is it makes you reflect across that y-axis. So I could draw a little highlighted line down the y-axis to show that A and B look like mirror images of one another because we just changed the slope from a positive to a negative. The same thing is true for C and D. Their equations look identical, but the slopes, one's positive and one's negative. And again, we see that mirror image up here. So what do you notice is that when the slope changes from positive to negative, we create a reflection, or it reflects across the y-axis, or a mirror image of one another. So now we're going to summarize what we just talked about on this page. I don't want to show you answers. We're going to summarize this real quick. So go ahead and hit pause and see if you can fill in these answers for yourself. A translation, what happens? It moves up or down or left or right. That's a translation. What happens to the equation? If it's in the form of y equals mx plus b, then that means that the y-intercept, which is technically b, changed. Now, if at any point I'm talking or writing too fast, hit pause or slow down the playback of this video. This line on every single one of these graphs represents the original function y equals x. So an example of a translation would be maybe saying y equals x plus 3. So if I were to draw that line, it would look like this. And these are your notes, so you can go ahead and do that. If some people would consider that this looks like it moved to the left because they're noticing how the x-intercepts change as opposed to how the y-intercepts changed. So whether you say it moved left 3 spots or moved up 3 spots is up to you. So I might write that, because these are my notes, and say it moves up 3 units or left 3 units. Hit pause and consider what happens with a rotation. The graph appears to turn, or the steepness changes. Steepness changes, which is also known as a stretch, making it look longer, or a compression, basically pressing it down. What happens to the equation? Well, we talked about how the slope changes. So if this is y equals x, the original parent function, an example of a rotation would be maybe changing the slope from a 1 to maybe 1/3. So I'm still going to start at 0, but I'm going to go up 1 over 3, up 1 over 3. So that line's going to look like this. So I would say that this example is less steep than the parent function, or I could say it was compressed, because it looks like it was kind of smushed and flattened. Hit pause and consider reflection. What happens to the graph is that it looks like it reflects across the y-axis. What happens to the equation is that the sign, which is plus or minus, of the slope changes. So if this is y equals x, the parent function, if I did y equals negative x instead, so instead of positive 1 for a slope, it's a negative 1, then it's going to look like this. And so I would say that it reflected across the y-axis. Okay, so this is the end of the notes. Here is what you are going to do. You are either going to go back and finish page 7 and 8, or you're going to do level practice using your self-assessment as your guide.